Tesla Model S Plaid battery pack is an engineering masterpiece. February 13, 2022. Sandy Munro of Munro & Associates continues to tear down a Tesla Model S Plaid. And this time the battery pack, onboard charger, and DC-DC converter were analyzed. The automotive expert is amazed at the manufacturer's architecture and foresight, calling the battery pack an engineering masterpiece. The first thing that catches your eye when looking at the Model S Plaid battery pack is the mica shield that is bolted to the steel frame. Perhaps this was done because China now has strict fire safety requirements for electric vehicles. So some companies have begun to install a mica shield on the battery. Tesla probably did the same, though Sandy cannot be fully sure. Tesla uses casting parts to separate the battery modules, of which there are 5. These parts not only separate the modules but also perform other important functions in the package. The internal castings are made in 2 different styles, due to the different mounting methods Tesla uses to hold the battery to a body in white. There are also some castings on the outside, which are needed in order to reduce the total number of parts used and effectively place everything that is needed there. Tesla has changed the battery architecture from what it was originally. There used to be 2 modules in the front of the battery. But now there's only one that houses the onboard chargers, allowing for more space for the battery cells, which are more in the Model S Plaid than in the previous Model S. The 85 kilowatt battery pack used to have 7,104 cells. But now, thanks to the extra space added, the Plaid has 7,920 battery cells, totaling 100 kilowatts. Previously, the battery pack had an efficiency of 157 watt-hours per kilogram. And in the Plaid it is 181.5 watt-hours per kilogram. Thus, the battery can receive more charge with less weight. The onboard charger and DC-DC converter for Model Y and Model S Plaid appear architecturally very similar at first glance, which is due to the fact that Tesla often uses the same components for different models in an attempt to reduce production costs. In addition, Model S Plaid uses fewer small and insignificant components and materials, resulting in a total savings of about 3 pounds in weight and therefore lower manufacturing costs. Sandy points out that Model 3 and Y units always had room for additional fuses, but they were never inserted. However, this was done on Model S Plaid, which is a stunning demonstration of how the company already had plans for this a long time ago. Also, the number of transformers has been increased to 4 from 2 in Model Y, indicating that they are doing something with the power that goes through there. However, more details about this are yet to be revealed. Source reposted and summarized from Eva Fox at Tasmanian. My take: Munro is the expert. If he is impressed, then I am satisfied with how great it is. Tesla may triple capacity with breakthrough cathode chemistry. February 13, 2022. As Tesla with its Model Y and Model 3 grows in popularity around the world, along with many other EV brands, scientists see great potential in lithium-sulfur batteries as a greener source of power, which can, by the way, triple current capacities. The main reason is that these batteries don't depend on the same kind of expensive and hard-to-source raw materials, such as cobalt. Up until now, other stability issues have held and hindered the technology, right until this breakthrough was announced on Communications Chemistry Journal last February 10. Engineers at Drexel University have made a breakthrough they say brings these batteries closer to commercial use, by harnessing a rare chemical phase of sulfur to prevent harmful chemical reactions. Lithium-sulfur batteries hold great promise when it comes to energy storage, and not just because sulfur is abundant and less problematic to obtain than cobalt, manganese, and nickel used in today's batteries. Additionally, they can offer a significant performance boost, with the potential to store several times the energy of current lithium-ion batteries. Will this new battery technology be a threat or a reliable ally for Tesla and its Model Y and Model 3? As far as we know, the 4680 cell aims to revolutionize lithium-ion batteries used in electric vehicles. It is 46 mm wide and 80 mm long and will increase energy density by 5 times, increase range by 16%, and improve power output by 6 times. The cell has been in development since 2020, kept behind the doors of the Cathode facility. Drew Baglino, SVP of Powertrain for Tesla, said that 4680 cells are not a constraint to our 2022 volume plans. He added that he expects the first vehicles equipping the 4680 cells to be delivered by the end of Q1 2022. Source reposted and summarized from Nicholas Caballero at Talk News. My take: I am 100% open to any new battery tech that helps the EV adoption happen quicker. There are so many now. Not sure which one will be the new standard. ICE car sales fall as Tesla sales rise. February 13, 2022. Last quarter, overall auto sales in the US slipped. But EV sales surged. Kelley Blue Book reports that total car sales fell by 21.3% in Q4 2021 compared to Q4 2020. While EV sales grew by 72%. Is this the beginning of the end of the oil age? Or just another temporary COVID-induced distortion of the normal market? Let's look at the case for the former. In most positive scenarios of the clean energy future, individual car ownership will decline in response to a number of factors: more internet-based work, better public transport and more walkable cities, and new shared ownership models. Some, notably Tesla's Elon Musk, believe that autonomous vehicles will be in service most of the time, instead of parked most of the time, so that fewer will be needed. On the other hand, there are several reasons to be wary of extrapolating a long-term trend from sales stats from one highly unusual quarter. By all accounts, the reason for tanking auto sales lies on the supply side. People still want to buy cars, as the sky-high prices for used vehicles, and the unattractive practice of auto dealers slapping high markups on in-demand models, make clear. However, automakers are unable to supply them, due to the ongoing chip shortage and other supply chain problems. As for the fact that EV sales soared, it would be more accurate to say that Tesla sales soared. Kelley tells us that some 72% of all EVs sold in the US last quarter sported Tesla's cat's nose tee on their hoods. Tesla also dominated the overall luxury market, outselling gas models from Audi, BMW, Lexus and Mercedes. For several reasons, notably its in-house software development and its unified computer architecture. The chip shortage has proven to be far less of a problem for Tesla than for the legacy brands. It's hard to escape the conclusion that the reason EVs bucked the overall market decline is simply that all-electric Tesla had cars to sell, while the other, gas-centric brands didn't. Source reposted and summarized from Charles Morris at EVANNEX. My take: the ICE car manufacturers are hiding behind the chip shortage excuse. They actually have a real demand problem. The writing is on the wall. The ICE age is over. Ford hires former Tesla engineer to lead advanced EV development. February 13, 2022. Ford has hired former Tesla engineer Alan Clark, who left the company over 12 years to oversee Ford's advanced EV development projects. According to Clark's LinkedIn, he accepted the position this week and officially joined Ford in California. At Tesla, he spent over 12 years in the company's engineering department. In September 2009, he joined Tesla as the senior design engineer on Model X and Model S projects, including the advanced engineering processes for the drive unit, drivetrain, voltage distribution, and closure panels for the all-electric SUV in January 2012. Clark was promoted to the senior manager of new programs engineering, where he oversaw the engineering and development of advanced prototypes and future models at Tesla's Los Angeles Design and Engineering Center. He then moved to Director of New Programs Engineering until leaving Tesla in January 2022. Source reposted and summarized from Joey Klender at Tesla RT. My take: this is a great move for Ford. If they want to survive, they need some help from real experts.